Hello everyone and welcome back to the third video in the series AI Foundations for Developers. In this video, we are going to talk about something that sits at the core of the modern AI systems, vector databases. If you have worked with AI, you have probably heard terms like embeddings, semantic search or RAG. But what exactly is a vector database and why do we even need one? By the end of this video, you should have a clear mental model of what a vector database is, what problem it solves, and where it fits in a real-world AI systems. Let's start with something familiar, traditional databases. Databases like MySQL or Postgres are excellent when you know exactly what you're looking for. You can filter data, you can join tables, and run aggregations efficiently. But they completely fall apart when questions become more vague or meaning based. For example, you are not looking for an exact match, but something similar in the meaning. That's where the problem begins. Let's look at a simple example. Suppose someone searches for how to save battery on my phone. Now imagine an article titled 10 Tips to Improve Smartphone Battery Life. There are very few overlapping keywords here. A traditional database or keyword search might miss it entirely. But as humans, we instantly understand that both are talking about the same thing. This ability to understand meaning is exactly what semantic search tries to replicate. To enable semantic search, we convert data into embeddings. An embedding is just a long list of numbers, sometimes hundreds or even thousands of numbers long. Each number represents some learned feature of the data. So instead of comparing words, we compare vectors using distance. The closer two vectors are, the more similar their meanings are. One obvious approach is brute force. You take the query vector and compare it with every single vector in your vector database. That works fine when you have few hundred vectors, but when you have millions or billions of embeddings, this becomes impossibly slow. Even powerful hardware can't save you here. So, we need smarter way to search. A vector database is a system designed specially to solve this problem. It stores embeddings, builds special indexes on them, and allows you to quickly find vectors that are approximately the closed match. The keyword here is approximate. We sacrifice a tiny bit of accuracy in exchange for massive performance gains. And in practice, that trade off is almost always worth it. Think about searching for a house. A house can be described by many features: price, location, size, number of rooms, and so on. Together, these features form a multi-dimensional representation. When you look for similar houses, you don't inspect every house in the country. You narrow down the search intelligently. That's exactly what vector databases do with embeddings. This is how vector databases fit into modern AI systems. Raw data like text, images, or audio is first converted into embeddings. Those embeddings are stored in vector databases. When a query comes in, it also converted into an embedding. The vector databases then retrieve the most relevant results based on the similarity. This pattern shows up everywhere in the modern AI. One popular vector database is Milvus. Milvus is open source and designed to handle large embedding workloads. It's cloud native, distributed, and built for production use cases. It's commonly used in the systems that deals with millions or even billions of vectors. Milvus separates different responsibilities into different components. Query nodes handle search requests. Data nodes manage stored vector. Index nodes build and maintain search indexes. This separation allows Milvus to scale efficiently and handle high query loads reliably. If you have used relational databases, this part will feel familiar. A collection is similar to a table. A schema defines what fields exist. The main difference is that vector fields are first-class citizens and not an add-on. Milvus separates raw data from indexes. Raw vectors are stored cheaply where indexes are optimized for fast search. This makes it easy to rebuild or change indexes without touching the original data. It's very flexible and efficient design. Indexes are one of the most important concepts in vector databases. Different indexes offer different trade-offs. Some are extremely fast but use more memory. Others are slower but more memory efficient. Choose the right index depending entirely on your use case. When a search happens, Milvus follows a clear pipeline. Query is converted into embedding, the appropriate index is used, and an approximate nearest neighbor search is performed. After that, metadata filters are applied and the top results are returned, usually in milliseconds. Hybrid search combines multiple signals. Dense vectors capture semantic meaning, sparse vectors capture keyword relevance, metadata filters add constraints like time, user, or category. Together, they produce much better results than any single approach. Vector databases are powerful, but they are not always necessary. If your problem is simple and exact matching works, a traditional database is often enough. Use vector databases when meaning, similarity, and scale really matters. To summarize, vector databases are a foundational building block for modern AI systems. They make semantic search possible at scale and act as a long-term memory for AI applications. If you are building RAG systems, AI agents, or intelligent search, vector databases are hard to avoid. In the next video, we will move from concepts to implementation. We will introduce LangChain and connect it with Milvus. Then, we will load real-world documents, generate embeddings, and store them in vector databases. After that, we will perform hybrid search using both semantic meaning and keywords. And finally, we will see how all this forms the foundation of building AI agents with memory and retrieval. This is where everything we discussed today starts coming together in real code. Thank you so much for watching, and I will see you in the next video.